Okay, this is the video lesson for Algebra 2, 10.2 Parabolas. So this is the first conic section we're going to focus on. Since we already have some familiarity with it, we're going to learn how to write an equation and to graph them. So this is using just a little bit different than what we did before. Instead of using the zeros, we're going to be using what we call a focus and a directrix. And so if we read the definition of parabola here, this is parabola is a set of all points in a plane that are the same distance on a fixed from a fixed line and a fixed point not on the line. So in this case, the fixed point is called the focus of the parabola. So if you look at the parabola opening up like this little point here is called the focus. And then the fixed line is called the directrix. Let's call that there. And you can see here from the focus and from the directrix, this length and this length, called the focal length. The distance between the vertex and the focus is called the focal length, sorry. In the vertex and the focus, sorry, this is the focal length here. But this length here is going to be the same as this length here, and it's going to be changing. That's why that's not a name here. But that's the definition of a parabola. So anywhere on the parabola, like see even down here, the distance between, let's see if I can zoom in here. The distance between the focus and the parabola is going to be the same distance as the directrix and the parabola. So here you can see this length is the same as this length. And as you move along here, like say this is the point, this length from the focus, and then this length from the directrix, these are going to be congruent. Right, so this length is always going to be the same. And that's the definition of a parabola. In order to find the focus of a parabola or the directrix, we use these formulas. And I realized these formulas are incorrect. Well, one of them is, and it's this one right here. We're talking about vertical parabolas and horizontal parabolas. I know we have already talked about vertical ones. They also go upside down here. But horizontal parabolas, they're not just not functions, but they also work with this as conic sections too. But here the focus is going to be on the x-axis, which means its formula is not, or its point is not 0c. That would put it on the y-axis. For a vertical parabola, it should be, and I'll change your notes, so they'll say it's c comma 0, which will put it on the x-axis. So moving on from there, make sure your notes have that corrected. The book should have that correctly. Okay, so let's move on to what is an equation of the parabola with a vertex at the origin and a focus 0, 2. So here we have a focus 0, 2, which means our parabola is going to go vertically because the, oops, didn't mean to move that, because the focus is of the form 0, comma, a number, which means it's vertical. And so if our C is 2, then we just have to say, plug in, use our equation here. Y equals 1 over 4 times 2 x squared. So y equals 1/8 x squared. And that's our equation. I did put this here to graph, but I think that might not confuse you, but I don't want to take away from, make this too long of a video. But this is just asking for the equation. This is the equation. And you have the formula here. You find your C is 2, and you just plug in your 2. Okay. Moving on. I think what really helps with these is having your equations. So I rewrote them onto this page so that we would have them there too. This wants, we want our vertex, our focus, our directrix. Since our equation is like this, of this form, we know that our vertex is 0, 0, right? Because we took them from the list that says the vertex is 0, 0. So that's why the vertex is 0, 0. We just need to figure out our C. So since our A is 1 over 4c, and the A here is negative 1/12, we just have to set them equal to each other. Negative 1/12 equals 1 over 4c, and that's how we find our C. We can just see here that this needs to be a 12, so C is going to be 3. But you could just, if you don't see that, actually that's not true. It's supposed to be negative 3 because this needs to be negative. But if, just to make sure you don't make mistakes like I just did quickly, you can just cross multiply. 12 equals negative 4c, and then divide by negative 4. So c equals negative 3. And then you just plug into your formula. 0, negative 3. And directrix is y equals 3, right? Because negative 3 is 3. So there's your answers. Okay. So now try these on your own. You just need an equation of a parabola when you're given the focus and the vertex at 0, 0. It means you're using these formulas. So figure out your equation for this one. And then for this one, just find the focus and the directrix. This is our, I think I was supposed to write vertex, but you already know the vertex is 0, 0 because it's of this form, which matches this form, which is under the vertex 0, 0. So try these, press pause, and check back for the solution. Okay, hopefully these were pretty simple for you. For C, you just had to plug in, for this C, you can see that C is negative 1/2 from here, 0C, and so you just have to plug in the C into this formula here. 4 times negative 1.5, you can use a calculator, and that's negative 6. I didn't there, and then you just plug that in there. So it's negative 1/6 times x squared. That's your equation. Then in this one, you also need to solve for C. Your A is 1/4, so that is 1/4C, so C has to be 1. Right, so your focus is just 0, 1, and your directrix is y equals negative 1. So hopefully that's not too bad. You really just need the formulas. Let's see now horizontal parabolas. Again, remember I wrote this originally wrong on your notes. I was writing them too fast. The focus here is going to be C, 0. So it'll be on the x-axis. The equation of parabola with a vertex at the origin, so that's here. So we're using these equations here. And we know that it's horizontal, even because it's on the section. I'm telling you it's horizontal, but because the directrix says x equals, which is a vertical line, which would be like this. And so that means the parabola doesn't cross that line. So it's not going to go here or here or here. It's going to be going this way, right? And the focus is opposite that, right? C, negative 1, so it would be right there. And so actually that's the focus. Our actual one's going to look, and our vertex is here, something like this. Okay, anyway, I'm not drawing the graphs for these, but just want you to get an idea of how this changes and how they look. So if the directrix is 1.25, that means negative C equals 1.25, which means C equals negative 1.25. And since our equation is x equals 1/4 times C, we can just multiply that by negative 1.25 y squared. And that means the equation, if you just multiply 4 times negative 1.25, you get negative 5. So this is just equal to 1/5 negative y squared. And that's your equation. Okay, and then for this one here, the vertex is, since our equation is of this form, my vertex is 0, 0. In order to find the focus, right, it's going to be C0, we need to find C. So 1/4C is equal to 0.75, which is 3/4. So if we cross multiply this, we would get 12C equals 4. Divide both sides by 12, C equals 1/3. So my focus is 1/3, 0. And my directrix is x equals negative C, so it's x equals negative 1/3. So that's all. Just gotta find your C, plug it into your formulas. Okay. So now I want you guys to try these on your own. Again, let me fix, I wrote this on every page now. The focus here is C, 0 for these. So first one, write an equation of a parabola with the given directrix, then find the vertex, focus, and directrix with the given equation. So press pause, try these on your own, and then check back for the solution. Okay, hopefully this wasn't too bad for you. Negative C was negative 5/2, which means C was 5/2. So just plug that 5/2 in here. Multiply that by 4, you get 10, so it's 1/10 y squared is the equation, x equals. And then for this one, the vertex is at the origin. based on the equation. And so we just need to find C to do the focus and the directrix. Negative 4 equals 1 over 4C. Cross multiply, negative 16C equals 1. And so C is negative 1/16. So the focus is negative 1/16, comma 0. And the directrix is x equals 1/16. Okay, so getting a little bit more in depth here. This kind of just explains, this is kind of cool. This is like real life parabola. This says the geometry of the parabola implies a very important reflective property that gives real world meaning to the word focus. This is why this is a focus, right? As light comes in, so this is actually a parabolic reflector, this picture. And it shows that if a light is coming in horizontally, right, and it just reflects off and it all goes to the focus. Right, so if there's one coming in this angle, it reflects off there and goes right to the focus. So that's why where the word focus comes from. And this is how a flashlight works. So conversely, right, lines parallel to the axis of symmetry off the parabola are directly into the focus, and that's how a satellite dish works. Okay, right, see if it's coming here. Boom. Okay, so here we have our table, which shows, and this is what I've been using for the ones where the vertex is at the origin, right? So if you have a vertical parabola, vertex at the origin, these are your equations, and then horizontal is here. So moving on to the vertex being HK instead of 0, 0, these are your formulas. So again, just like when we're doing transformations, the H gets subtracted from the X, that's how far you're moving left or right, and then the K gets added, or this, in this case, it's a little different. The parabola moves up or down K. So that changes the focus to be, if for a vertical parabola, H comma K plus C, you have to add the C to your K, because the vertex is HK, right? And then for a vertical parabola, the vertex and the focus are going to have the same X coordinate. The horizontal one, they will have the same Y coordinate, the K. And that, right, the K is what's being subtracted from the Y. So whatever's being subtracted from what's being squared is your coordinate that stays. Okay, so now we're going to be using these formulas. So it takes a little bit, they're a little trickier, but as long as you have them, I don't think they're too bad. You just do some practicing with them. So let's look at this first. Okay, so problem 3, we have a solar reflector. The parabolic solar reflector pictured here has a depth of 2 feet. At the center, how far from the vertex is the focus? So here they're saying this is 2 feet. And then from the picture, since this is 8 feet, this is 4 and this is 4. And they want to know how far away the vertex is from the focus. So what we want to do is use the equation of a vertical parabola. Here, in this case, the vertex, let's call this the origin. So we can actually make a graph of this, right? This is going to be 2 feet. So this is 2, and then this is going to be 4 and 4. Okay. So we know that this point is 4, 2, and this point is negative 4, 2. So if since we have it's vertical and it's at the origin, so it's basically what we've been using before. Oh, why did that move with that? That was weird. Let's see if I can undo that. Here we go. Okay, but the formula is y equals 1 over 4c x squared. And so we know that to find c, we can just plug in this x and this y. So let's put the 2 in for y. Let's put the 4 in for x, and this becomes 2 equals 1 over 4c times 16. And then this 4 cancels with that 16 to be a 4, and we can multiply. So this becomes 2 equals 4 over c. We can cross multiply like that. 2c equals 4. So c equals 2. Okay, and so that means this this actually is our focus. 0, 2 is the focus, and it asks for how far away is the vertex from the focus. Well, actually, when we started the problem, we knew the focus was right here, right? They told us it is 2 feet. So this is 2 feet, but we didn't know necessarily that that was the focus. And so we did find out that that was the focus, so this length here is 2, and that is the focal length, the length from the vertex to the focus. Okay, so here's one for you to try. Ooh, this is so weird. I gotta move them both at the same time. Okay, there you go. I want you to try this one. A mirrored reflector of a flashlight is 8 centimeters across and 4 centimeters deep. How far from the vertex should the light bulb be positioned? This is asking for, right, again, it's the focal length. This is asking for the focal length. Okay, so try this one on your own and then check back for the solution. Okay, so for doing this one, you can find, right, if this is the 8, right, it splits at 4 and 4, and then if this is my 0, 0, this length is 4. So this point is 4, 4. And if you plug that into your formula, the equation, then you find that C is 1. So that means the focus is at 0, 1, which means the focal length is 1 centimeter. So hopefully you got 1 centimeter. Okay, is there anything else? Nope. All right, that's fun. Okay, again, I put this table here to help us because now we are doing, that one actually still had vertex at 0, 0. That was more of a real world problem. But here now we're going to use where the vertex is different than the origin. So this is asking for the vertex, the focus, and the directrix of the parabola. And we're going to use, so here we have y and x squared. It is not of this form because we have this b and c on here. So that means the vertex is hk. And so we need to figure out what the c is. So we can, well, also h and k to get the vertex. So we do know, remember back from our quadratic days, that the vertex, right, hk, where h is negative b over 2a. So in this case, a is 1, b is negative 4, and c is 8. So that makes this positive 4 over 2 times 1. So 4 over 2 is 2. So this means our vertex is 2. Our x coordinate is 2. And then we can plug in the 2 to find the y. 2 squared minus 4 times 2 plus 8. This is just a review of quadratics. 4 minus 8 plus 8 is 4. So the vertex hk is 2, 4. So that is our vertex. Okay, and then our focus is going to be, well, remember that we said that a, right, this is our coefficient in front of our equation. So this is actually the a. So even though it's not in the same form, this is still the a. So in this case, 1 is equal to 1 over 4c. So whatever your a is, that's another formula you can just put or have, if that makes sense. And then this becomes 4c equals 1, so c is 1/4. So then the focus, and this is a parabola that, just a regular parabola that opens up. So the focus is going to be on the y, not the y-axis, but the vertical line. And remember here, it's going to be hk plus c. So in this case, my h is 2, and then my focus is, well, my k is 4, and my c is 1/4. So my focus is 2, excuse me, 4.25. I'll change that to a decimal. So that's the focus. And then the directrix is just that y equals k minus c. And in this case, k is 4, and c is 1/4, so this equals 3.75. So this is y equals, it's a line, remember. Okay, and we'll get to graphing later. I won't make you graph right now or watch a graph, but just using these formulas here to answer these questions, right? You find the vertex, the focus, and the directrix, then you can basically graph it. You just need a couple more points. So try this on your own. Use what we know about what we learned for quadratic functions to find your vertex. Once you have your A, your B, and your C. The book wants you to complete the square to do this and put it in basically vertex form, which you can do. I'm not going to show you. It's nobody likes completing the square. So here's a nice formula that you can just use. And just remember that, right, this is ax squared plus bx plus c, if that is true for your y. then that means A equals 1 over 4C for this parabola, and then for, I don't know why I was saying that. Maybe I'll remember. Okay, so to find your, oh, I was going to write this. Your vertex obviously is h comma k, and then your h equals negative b over 2a. I was just trying to write your extra formulas in here. And then to find the k, right, you just plug in this x value into your, like, so it's f of negative b over 2a. That means, right, we took this number 2 and we plugged it into this x and this x and this x, and that's not an x, just these two x's right here, right, to figure out what the y was, or the k. Sorry, not. Okay, so try that on your own down here. Press pause and then check back for the solutions. Okay, hopefully that wasn't too bad. You just use this formula to find your h, which was negative 4. Plug that into your original formula to find what k was, which was 2. So your vertex is at negative 4 comma 2. Use your a to find your c, which was 1/4, and then plug that into your formula for your focus, which would be negative 4 comma 2.25, and then the directrix is k minus c, y equals k minus c, which was y equals 1.75. All right, last page. Okay, but as I went to the next page, I realized that we don't actually graph on the page, so I am going to make you graph here. So let's go back up to problem 4. Now that we have the vertex, the focus, and the directrix, let's graph this. Okay, so our vertex is 2, 4. It's right here. And so our directrix is y equals 3.75. So it's very close to our vertex. Should have made that black. And then our focus is just right above it. And then if we plug, and then let's plug in 4 to find a point. So 4 squared minus 4 times 4, so that plus 8. So this would be just 8, because this is 16 minus 16. 1, 2, 3, 4, 5, 6, 7, 8. All right, this is going off. And axis of symmetry, so it's going to look like this. Oh, no. It is not. What did I do wrong? That's my vertex. I mean, that's my focus, not my vertex. Here we go. Just off a little. Let's make these yellow. That was my problem. I was using the black. There we go. Okay, and then this one. I should have been graphing the other one. Sorry. I just really wanted to keep this kind of short, but it's not so long. Okay, negative 4, 2. That's my vertex. And then my focus is, or did I zoom these out? Y is 1.75. So this is going to look very similar. It's really close. And then the focus is just right up there. And then if we plug in 2, 2 squared is 4 plus 2 times 8 is 16. 20 plus 18. Ooh, that's going to shoot up fast. So way up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Really? All right, I'm just going to shoot up like this. Okay. There's your graph for that. All right, now we're going to this last page. Here are your formulas. Problem 5 asks, which is an equation of the parabola with vertex 3, 7, and a focus of 5, 7. So we can see that the k's match, right? So that is going to be where the vertex matches this. So this is going to be a horizontal parabola. So that means it's going to be this equation. So it's going to be x with the y squared. And then you're just going to be subtracting your k. So this is going to be x equals 1 over 4. In this case, our c is, this is h plus c. Since our h is 3, this is 3 plus 2 to get 5. So c is 2. So this is going to be 1 over 8 y minus our k, which is 7 squared, and then plus h, which was 3. There we go. I don't think actually in a multiple choice that you have to do all that work, because you can kind of see yeah, that we knew that it was x, so that we got rid of this, and then we knew we were subtracting 7 and adding 3. So we did need to find the c between these two. Okay, we did have to do all that work. All right. Makes sense, right? You again just got to use these formulas and just get used to them, practice with them, practice with them. Okay, and then this last one, what is the equation of parabola? So it's not multiple choice, so we have to see what matches. The h's match. So this is going to be a y equals 1 over 4c x minus h squared plus k. It's going to be a vertical one. And so our focus is k plus c. So h is 1, k is 4, so k plus c equals 6, and it's 4 plus c equals 6, so c is 2. So this is y equals 1 over 4 times 2 is 8, h is 1 minus 1 squared, and then k was 4, plus 4. Oh, that was one that I was supposed to have you do on your own. Sorry, I'm sure you're ready for this video to be over if you're even this far. Good job. Whoa, that's weird. I don't know what that was. Interesting. Okay, good thing this is over. Enjoy. There's your practice. Have fun. Please email me with questions.